Alright, so welcome to the third video. This video is going to be about theoretical and percentage yielding. The problem says the following. The reduction of iron ore takes place in the blast furnace for the extraction of iron. The equation for the reaction is, and it gives the equation. Then it says a mixture of 30 kilograms of iron 3 oxide and 5 kilograms of coke, which for purposes of the problem we will assume that is pure carbon. They say that those two are heated until no further reaction is taking place. The two questions that need to be answered are calculating the maximum mass of iron that can be obtained from this reaction mixture and calculating the percentage yield of iron if the actual yield is 14 kilograms. So let's just jump into part A, which asks us to calculate the maximum mass of iron that can be obtained from the reaction mixture. Now for this, we need to determine which one of the reactants is the limiting reagent, whether it is iron 3 oxide or whether it's carbon. We need to find out what the limiting reagent is. So for that, we need the molecular masses of carbon, which is easily obtained just by looking at the periodic table, and of iron 3 oxide. Now for iron 3 oxide, it requires a little more calculation, but we'll just follow the procedure of multiplying the subscript of iron times its molecular mass, which is 55.85, and multiplying the subscript of oxygen times its molecular mass, which is 16, and adding those two. So if we add the two multiplications, we obtain that the molecular mass of iron 3 oxide is 159.7 grams per mole. Now, having both molecular masses of iron 3 oxide and of carbon, we now need to calculate the moles. So for this, we must divide, in order to cancel the units, we must divide the mass by the molecular mass. So that way grams will cancel and we'll just be getting moles, which is what we want. Now, take into account that the values given in the exercise are given in kilograms and they must be in grams in order for the operation to work. They must be in standard units. So, in order to calculate the amount of iron 3 oxide, would be multiplying that 30, that mass, that 30 kilograms times 1,000 to get to grams, and then dividing that by its molecular mass, which we have already calculated, it is 159.7. If we do that, we obtain that the amount in moles of iron 3 oxide in the reaction is 188. Now we do the same for carbon. We get that 5 kilograms, we multiply it by 1,000 to get 2 grams, and we divide it by its molecular mass, which we obtain from the periodic table, and it is 12.01. We do that, we get that 416 moles are present in this reaction of carbon. Now we look at those two, and we determine that the limiting reagent is iron 3 oxide, as there are less moles present in the reaction. This is why it is highlighted in yellow. Iron 3 oxide will be our limiting reagent and will be the reagent that we will be working when moving forward. So now we have identified what the limiting reagent is, we need to figure out the ratio of that limiting reagent related to the product that we want. So the product that we want is iron. Now locating iron in the product side, iron is here. And so we need to determine the ratio. Now we have that 2 moles of iron 3 oxide react and 4 moles of iron as a solid are produced. So the molar ratio of iron 3 oxide to iron is 2 to 4, which simplifies to a 1 to 2 ratio. Now taking this relationship into account, we can get that the amount in moles of iron produced is twice the amount of iron oxide that is reacting. Now we know that amount, we have calculated it, so we just multiply that amount times 2 and get that the amount in moles of iron produced is 376. Now that we have moles, we multiply that by the molecular mass of iron, and we get 21,000 grams. By canceling the moles, we get 21,000 grams or 21 kilograms of a maximum mass of iron. So that'll be part A. Now part B says that if the actual yield of iron was 14 kilograms, what is the percentage yield? Now let's remember that the formula for percentage yield is the actual yield divided by the theoretical yield times 100. Now the theoretical yield in this case would be the amount that we calculated in the previous exercise, as this is the maximum that can be produced with this reaction if there's no heat loss and if there's no other determinant. We have that theoretical yield is that 21 kilograms, and we have that the actual yield was 14 kilograms. So we divide 14 by 21, and as the units are both in kilograms, that's fine to leave it like that because we're going to get a percentage. So we divide 14 by 21, multiply times 100, and we get that the percentage yield of iron in this reaction is actually 66.7%. That would be part B of the exercise. That would be that would finish the problem. I hope you learned about theoretical and percentage yielding. And again, the presentation is linked in the description if you need to use it. So thank you for your time.